Hello, dear GMAETS 41 students. You are welcome to our chemistry class. In our live class today, being Wednesday, we are going to give attention to how to write the correct chemical formulae of trinary compounds. Trinary compounds. Now you recall that in our previous chemistry class last week, Wednesday, we learned how you can write correct chemical formula of binary compounds, where I explained that binary compounds are made up of two elements. And all of this idea of writing correct chemical formula of a compound is based on the knowledge of valency. Valency of elements, valency of radicals. And then I also opened your eyes to also understand that all of these are traceable. They come from our unique knowledge of valence electron, which is the number of electrons in the outermost shell of an element. So we're going to continue. We'll be giving attention to trinary compounds today. Trinary. So we are going to ask ourselves, what are trinary compounds? So I want to believe that someone out there already taking this lesson likely know what trinary compounds are. The word tri already gives us the idea. So can someone out there tell us what trinary compounds are? Compounds that contain how many elements? Is it 2 elements or 3 elements? And I know for sure you will be thinking and saying right there with you that trinary compounds, they contain 3 elements. And of course, you are super correct. If you join this class, please right away share the link to this class to your friends. Invite them to join this class. If you belong to any science group, share the link to this class to that group so that like minds can also connect to this class and learn how to write correct chemical formulae of compounds. This class specifically targets scholars, students in grade 10, grade 11, grade 12, 100 level in university, and perhaps 200 level. And any other student that still has challenges on how to write correct chemical formula of a compound. So we have defined trinary compounds. Trinary compounds are compounds that contain 3 elements. But I want us to break it down further. Is it possible for us to look at trinary compounds as compounds that contain 2 species, rather than saying contain 3 elements? Can we reduce that element to the concept of species? So we can now say that trinary compounds, they contain 2 species. One of the species is generally an ion of an element. And the other species is also an ion, but an ion that has a specific name called radicals. So we look at trinary compounds. They will contain metallic ion, right? And then they will also contain radicals. You know, if you come to radicals, you usually have 2 elements in a radical, right? 2 atoms of different elements. They make up radical. So this is going to guide us as we now look at how to write correct chemical formulae of trinary compounds. So all in all, what are the things you need to bear in mind? I don't know, the network is hanging a bit from here. Let me check from that end. Remember, once the network over interferes, we'll boost the network. I'll boost it so that we can have a lovely class. Buracus, thank you for your comment. Your answer is correct. I just saw your comment there stating that trinary compounds, they contain 3 elements. You are absolutely correct. You are absolutely correct. Is that okay? So we're going to move on to deal with how we can write correct chemical formula of a compound. But the secrets, like I said, you want to always remember, valence electron has already given us the secret into valency. Valency, very important. So you want to know valency of elements, valency of what? Elements, and then valency of radicals. Valency of what? Radicals. To be able to write correct chemical formula of trinary compounds. Once you know valency of elements and valency of what? Radicals, the problem is solved. In previous class, I already taught you about common radicals. Now also remember that I have highlighted the concept of valency of elements, and I urged you to make sure you get to learn the valencies of elements very well and that of radicals. So let us go straight on with our first compound. So the first compound we are going to give attention to will be calcium trioxocarbonate 4. Calcium trioxocarbonate 4. Carbonate 4. Now, from the name of the compound, we can actually come up with the elements that are present. Calcium. Then that tri is a number, so we have no business in terms of, okay, the elements present. We move on to oxo. That oxo is the prefix of oxygen. And then finally, we have carbonate from carbon. So these are the 3 elements present: calcium, carbon, and oxygen. But there is one thing you want to take note of. Remember, I stated that trinary compounds are generally made up of 3 elements, which can be broken down to 2 species. One, generally, a positive ion, and then the other will be negative radical. It is only in the case of ammonium that will have a positive radical. Don't worry, we'll treat that as we're moving on. So this guy, we have calcium. Now, this is what I usually do. The other part will have something like trioxo, tetraoxo, and the rest of them, heptoxo. I always encourage students to give attention to the radical that is present there. So instead of a student being worried much about the 3 elements, it's important to know the first element that is there, which is usually a positive ion. Are you following, right? Then the other one, put them together as radicals. That is why I taught you common radicals. And for those of you that have been following our classes, you have the list of common radicals already in your notes. So the trioxocarbonate, the radical is CO3, CO what? 3. And then the valency here, 2 minus, 2 minus. Are you following? But I don't want to show the valency yet. These are the things we have there. Now let us now write how this compound forms, calcium trioxocarbonate 4. First, we'll write that of calcium. Like I told you from the previous class, always write the positive ion first. And then it is going to combine with the radical. The radical is CO3, 2 minus. The radical is CO3, 2 minus. In fact, let me show this 2 minus here so that somebody will not be thinking that CO3 alone like that exists. No, it doesn't. It exists in ionic form. So look at it. I might just leave the valency of calcium, no problem. Here, I've shown you the valence of calcium. Then we have the valency of trioxocarbonate to be 2 minus. Okay, I've explained how you obtain that 2 minus from previous classes. So this CO3 together, its valency, its combining power is minus 2. You want to learn that? Visit our previous, I think, 2 classes or so, yeah. Now, when these 2 species combine, you know what happened? They will interchange their valency. This calcium will give its 2 valency to CO3. Take note. This valency of calcium will be given to this radical altogether. So the 2 will belong to carbon and oxygen together with these 3. Take note. Remember that this valency is what they are interchanging. Then this CO3 will give its valency to calcium. In our previous class, I told you that once they interchange their valencies, the valencies will now become atomicities of the elements that make up the compound. Where we define atomicity as the number of atoms of each element present in a compound. When this happens, you combine them together. So we're going to write the positive ion first, which is calcium. Calcium received 2. Valency of 2 from CO3, 2 minus, right? That is valency of 2 from CO3. I've told you from previous class that you don't show their charges. You don't. This plus minus, you don't show it when you step it down. You don't. Now, CO3 received valency of 2 from calcium. So you're going to write CO3. This CO3 normally is meant to be in brackets because you have 2 elements there. And the 2 elements there, the atoms of the element will be affected by this valency of calcium you are giving to them. So I'm going to step down subscript 2 here. And then we stated in our previous class, if you remember, when I treated that of binary compounds, we learned that once the atomicities are the same, cancel them, remove them. It is just like dividing this by 2, dividing this by 2. Divide through by the common terms or the common factor. Are you getting me right? Yesterday, I was actually talking about the importance of multiplication and as a basic arithmetic operation that develops the brain. And I explained in the basic class channel of GMAETS 41 the whole idea of common factor. So if you look at the atomicity here and the atomicity here, 2 is common to both of them. So what do? You can cancel out that 2. You divide through by 2. This compound you are seeing is still the same as someone writing Ca2, then carbon 2. Where did these 2 come from? These 2 outside, because it's affecting carbon. Then look at oxygen. Oh, oxygen already has 3 atoms. It will multiply these 2 to give you what? 6. And then, okay, you divide through by the common term, which is 2. If you divide here by 2, divide here by 2, divide here by 2, this guy will become what? 1. This will become 1. And this one will become what? 3. So that you now have Ca1, C1. If atomicity is 1, in our previous class, I explained that you don't write it, you don't show it. Are you following, right? A chemistry student, a science student is expected to know that this Ca alone, the atomicity is 1. So 1 is always invisible. Then you now write your oxygen with what? 3 atoms. So I am going to wipe off these 2 and wipe off these 2. I've shown you how this compound forms. So this is the correct chemical formula of calcium trioxocarbonate 4. Since there is no external number again, no need of putting this in brackets. The bracket I showed you here before is just to explain clearly that the 2 which calcium gave to this CO3, that is actually affecting both carbon and oxygen. That's just the reason why I had to put this in bracket with the 2 outside. So dear friends, calcium trioxocarbonate 4, this is the correct chemical formula, CaCO3. Anything else is wrong. Calcium trioxocarbonate 4 is not written like this. It's not written like this. This is wrong. This is wrong. The atomicity of calcium there is not 2. And calcium trioxocarbonate 4 is not written like this. It's not written like this. This is wrong. Because from what we saw here, the atomicity of carbon is 1. This thing I wrote here, the atomicity of carbon and oxygen together is 3. Since they are in bracket with these 3 outside, the 3 is affecting both of them. So you take note when you're dealing with correct chemical formula of calcium trioxocarbonate 4, this is the correct thing. Is that okay? Let's move on. I had stated in our last class that it is possible for you to talk about number of molecules. The number of molecules may be more than what we have here. Like this one now is one molecule. But I told you I'm not going to talk about molecule. Why teaching you how to write correct chemical formula of a compound? That is going to be a pre-recorded class. Are you getting me right? If you have not subscribed, make sure you subscribe to this channel. After subscribing, turn on the notification bell and select all, so that anytime I upload any content or maybe come on live like this, you will be notified if you really want to learn. You see science? Here at GMAETS 41, we breathe and speak science. So you don't want to miss our classes. Are you getting me right? Good. The atomicities of the elements in the compound. I told you from last class that it is not your mate. Atomicity is not your mate. Atomicity is standard. Once you know how to write the correct chemical formula of a compound, that is how the atomicity is meant to be. All the numbers written as subscripts here. You can see this is 1, this is 1, this is 3. You don't play with them. You don't touch them. If you know how to write the correct chemical formula, that is how the atomicity will be. But number of molecules may change. Whenever you are balancing chemical reaction, you see that. Is that okay? Whenever you are balancing chemical reaction, you see that. What is the difference between organic and inorganic chemistry? I think we are learning the concept of writing correct chemical formula of compound, yet hell on heels. Okay? However, take note. I just want to talk about this. Don't ask questions of what we are dealing with at the moment. This is a class. You cannot be talking about a particular topic and you're taking us to something else. In organic chemistry, you are studying compounds of carbon. If it is hydrocarbon you are dealing with, it will be compounds of carbon and hydrogen only. But if it is organic chemistry in its entirety, generally, it is the study of the chemistry of carbon compounds, that is compounds of carbons. But it does not include oxides of carbon. It does not include trioxocarbonate. It does not include carbon sulfide. Inorganic chemistry does not study carbon compound. It doesn't. Let's move on, please. Therefore, the correct chemical formula of calcium trioxocarbonate 4 is CaCO3. CaCO3. And you see the way we name trinary compound. Mention the first element, which is always a positive ion, a positive element. Metals, in most cases, generally. It's only in the case of ammonium, NH4, that you would have a radical there. Otherwise, the first element in trinary compound is always a metal. So you mention the full name, then jump to the last element. Mention the number of atoms of that last element. Use the Latin name, all right, or word for that number. Then usually you have like oxygen here. It's only in a few cases you could have something like hydrogen. This oxygen, mention the prefix as oxo. Then you come to the middle element. Mention the prefix and then end the suffix, the ending part of the name. End it with ate. That is why you have carbonate. Then of course you have carbonate 4. Don't worry. In our next class where I teach you calculation of oxidation numbers, you'll find out why this is carbonate 4. For now, just get to know how the compound is being pronounced. Calcium 3 is trioxocarbonate 4. Let us look at our next compound, please. We're going to talk about sodium. Let's look at sodium trioxonitrate 5. Sodium trioxonitrate 5. Now, from the name we have here, we find out that this compound contains sodium. Then the trioxonitrate 5 radical. Trioxonitrate 5 radical, which contains 2 elements. Oxo, nitrate. Nitrate is nitrogen. So we're going to have NO3. The valency of this radical is -1. So these are the species that make up this compound. What now is the correct chemical formula of sodium trioxocarbonate 4? We're going to use the valency knowledge. Are you getting me? So first, what is the valency of sodium? It is +1, positive 1. And you can see the valency of NO3 here. Valency of trioxonitrate is simply -1. So they are going to combine. You write a positive ion with its valency, then plus you write a radical with its valency. They are going to interchange their valencies. I'm not going to draw this again. I'm not going to draw. I've shown you how the valencies are being stepped down and interchanged to form atomicity. Now, this trioxonitrate 5 ion will give its valency, which is 1 here, -1, but you don't write the 1 when you don't write the minus when you are stepping down the valency. So bring down this 1 down here to sodium. Write the positive ion first, which is sodium. It will receive a valency of 1. That valency will become atomicity of sodium, as you can see. But I told you that if atomicity is 1, you don't show it. But let me still leave it anyway. Combine it with the trioxonitrate. Combine it with the trioxonitrate. Now, this NO3 together will receive the valency. Receive the valency of sodium. The valency of sodium is 1 plus 1. So just bring down 1 without the sign. Don't write the plus or minus. Take notes. Whenever you are stepping down the valencies and interchanging, the sign plus and minus, you kick them off. It's just a number that you interchange. Valency of 1, we don't show it. The atomicity of 1, rather, we don't show it. So I'm going to wipe that atomicity of 1. Once again, did you observe that this NO3, I had to put it in brackets? Then when this sodium was stepping down its valency to become atomicity of NO3, I now wrote this NO3 in bracket with the 1 outside, telling you that this atomicity is affecting both nitrogen and what? Oxygen. Take note. I have a reason why I have been doing this. I have a reason why. So we move on, you're going to find out in other compounds. At this point, let me wipe this one, wipe this one. You don't show atomicity of 1. Because there is no external number here outside the bracket, so you have to wipe that bracket too. Sodium trioxonitrate 5 is simply written as NaNO3. We conclude, therefore, the correct chemical formula of sodium trioxonitrate 5 is NaNO3. So we are done with this particular one. We shall be moving on to the next compound. Finish our words on the board. I'm going to wipe it right away. I'm going to wipe it right away. And then we move on to the next compound. Please do not play with this topic. Don't. It's a terrible thing for a student not to understand this topic in chemistry. Because once a student does not understand this topic, it becomes very, very difficult to follow up with chemistry. Imagine when talking about calculating the relative molecular mass of a compound. What about the molar mass of a compound? What about calculating number of moles, right, of a compound or a species, right? What about balancing of chemical equation? Someone would have problems with all of these things if you don't understand. You don't get to know how to write correct chemical formula of a compound. And by the time you move on in chemistry, you're dealing with all other aspects of chemistry. Think about metals and their compound, non-metals and their compound. If you come to their compound and then you see, let's say, preparation of ammonia, but you don't know the chemical formula of ammonia, or you see a particular subtopic where you're talking about the preparation of, let's say, tetraoxosulphate 6 from the contact process, for example, but you don't even know the chemical formula of tetraoxosulphate 6, then you're just not serious. Yes, you're not serious. What do I mean by you're not serious? Like, to survive that topic, and hence chemistry as a subject. So this is a backbone to you. I want to make sure you take this seriously. How to write correct chemical formula of a compound. We are looking at compound number 3. Let us consider tetraoxosulphate 6 acid, number 3. Tetraoxosulphate 6 acid. Sulphate 6 acid. Now, whenever you hear an acid, it's important for you to know that hydrogen is there. You don't need to wait for anyone to tell you that hydrogen is present there. Because one basic element that defines an acid is the presence of hydrogen. So tetraoxosulphate 6 acid contains hydrogen. Once that acid is mentioned at the end, then we don't need to mention the hydrogen. But listen to this, I could pronounce this compound as hydrogen tetraoxosulphate 6. In that case, I don't need to mention the acid. It's not necessary because the hydrogen I've mentioned already covers for the acid. But if I do not mention the hydrogen, I could just simply say tetraoxosulphate 6, then I have to end it with acid for someone to know that hydrogen is present. So we go based on what I've said here. We have hydrogen here. Hydrogen is the first guy. You know, I also pronounce this as hydrogen tetraoxosulphate 6. Now, the tetraoxosulphate 6 is a radical where you have SO4 2 minus. Good. So these are the components of this acid, tetraoxosulphate 6. Using the knowledge of their valencies, we can now find out the valency of hydrogen is +1. Then it's combining with SO4 2 minus. Let us see. When they interchange their valencies, what is going to happen? Write the hydrogen first. Hydrogen would get the valency of SO4 of the tetraoxosulphate 6 radical or ion. Hydrogen will receive its valency. The valency will become the atomicity of hydrogen. So you have H2. Then next, write this negative ion, SO4. This SO4 is meant to receive this valency of 1 of hydrogen. Hydrogen will transfer its valency of 1 to SO4. So normally this SO4 is meant to be in brackets with 1 outside. But because it is 1, no need of showing that. Are you following right? No need of what? Showing that. We are moving on. Maduka Chizaram, Oga, I don't tire. I don't understand what you're saying. If you are tired, go and tell your school that, so not me. Okay? Meanwhile, what is making you to be tired? You don't have to. You don't have to. One of the challenges you have these days is students usually get themselves occupied with so many unnecessary things. Remember, as a student, that word, I think, obtained from Greek, means studious. One of your main job now is to study. You have no choice except you want to disembark from furthering your studies. But as long as you're a student, calm down. There is time for everything. Don't be tired. These things are not difficult. You want to be committed to the process, and you can do it. Okay, Maduka can do it. Now, let us move on. The correct chemical formula, of tetraoxosulphate 6, tetraoxosulphate 6 acid is H2SO4. Any other thing apart from this is wrong. So you can see the atomicity of hydrogen is 2, the atomicity of sulfur is 1, the atomicity of oxygen is 4. An examiner can ask you, what is the mole ratio of the component element of a particular compound? I say that again. What is the mole ratio of the component element of a particular compound? Let us assume tetraoxosulphate 6 acid. The mole ratio will be hydrogen 2 is to sulfur 1 because they have atomicity of 1. It is simply the ratio of the atomicity that they are asking you of. And then is to 4 for oxygen. And that is that guy we try to obtain in empirical and molecular formula. So you see, you can be asked that question just to get the ratio of the atomicity. Let us move on. We don't have time. Let's talk about another compound. We're going to look at the correct chemical formula of ammonium tetraoxosulphate 6. Why this? ammonium tetraoxosulphate 6. Like I said, this topic, don't joke with it, please. Make sure you understand it very well. Once you understand it and then know the secret, because the secret of all of these things came from valence electron, which introduced us to valency of elements and radicals. Are you following? And it is from there we are doing all of these. Correct chemical formula of ammonium tetraoxosulphate 6. Ammonium tetraoxosulphate 6. Now, this is not an acid. It is not. Because you notice that you have this ammonium here is a radical. It's positive radical. It's not hydrogen. It is not hydrogen. If it was an acid, I could have mentioned acid at the end. But I have no need mentioning acid because I already have a positive ion from the beginning, which is not hydrogen. This is a salt. Under acid base and salt, you learn more about it. You know, it's a salt. Calcium trioxocarbonate 4 is a salt. Sodium trioxonitrate 5 is a salt. Chemical salt. Let's move on. Now, what are the component species of this ammonium tetraoxosulphate 6? The first one is the radical ammonium. This is a radical. The valency is +1. Then the next is the radical tetraoxosulphate 6, which is SO4. Its valency is 2-. Now, what is the correct chemical formula of ammonium tetraoxosulphate 6? Write the positive radical first, then combine it with the negative radical or species. You know what happens? They will interchange their valency. Then you write the positive ion first, combine it with the negative ion. Please let us watch. I am going to write my NH4, which is the positive ion ammonium. The ammonium is going to receive what valency from SO4? It's going to receive these two. The two valency here is going to step down and become atomicity of this NH4. This 2 is going to affect nitrogen, is going to affect hydrogen. That is what I have been showing you since. Where we had 1, 1. I'll have to put the radical in brackets, then 1. Later I'll wipe it because atomicity of 1, we don't show it. It's interesting to understand that here the atomicity of this NH4 will no longer be 1. Watch it. This NH4 is going to be enclosed in a bracket. It is receiving this valency of 2 from SO4. That valency of 2 become what? The atomicity of this ammonium. This NH4 must be in bracket because this 2 is affecting the 2 atoms of different elements in this ammonium. This is interesting. We shall now combine it with this negative ion, SO4. You know, this SO4 normally is meant to receive the valency of ammonium. And the valency of ammonium is 1. Which means normally I'm meant to put SO4 in bracket and then write 1 as its atomicity outside the bracket. But atomicity of 1, we don't show it. We don't. So I don't need to put SO4 in bracket and write 1 outside. It's not necessary because the atomicity that SO4 is receiving from ammonium is 1. So this is the correct chemical formula of ammonium tetraoxosulphate 6. Now, dear friends, let me tell you, just imagine somebody gives you N2H8SO4. Are you aware that this is also ammonium tetraoxosulphate 6? Are you aware? No wonder, how did we get this to be the same as this? It's simple math, multiplication. Simply multiply out the atomicities. Inside this bracket, the atomicity of nitrogen is 1 inside the bracket. Over here, are you following, right? So that 1 we multiply 2 to give you this N subscript 2. And then this H inside the bracket, the atomicity is 4. It must be multiplied by the number outside 2, making it 8. That is why you have H, and then the subscript, which is the atomicity, now becomes 8. Then SO4. So ammonium tetraoxosulphate 6 could still be written as this. But this is how we write it generally. Because even in this format, you observe that 2 is what? Common here. So you can divide this by 2, divide this by 2. Somebody may not wonder, but we have 4 here. Why can't we divide this 4 by 2? No, you don't do that. because 2 is not common with the other atom combined with oxygen. 2 is not there. I hope we are learning. Let me wipe this. We can conclude, therefore, the correct chemical formula of ammonium tetrasulfate 6 is NH4 in brackets with atomicity of 2 outside and then SO4. Any other thing apart from this is wrong in terms of the correct chemical formula of ammonium tetrasulfate 4. Any other thing apart from this is wrong in terms of the atomicity. Like I said, the atomicity is none of our mates. The atomicity is not even my mate. It is my senior, right? Because it's a standard. And you don't need to be worried about atomicity of compounds. Once you have excellent knowledge of valency, are you following, right, of elements and radicals, then you don't have problems with getting atomicities of each element in the compound, which must be according to standard, like I'm showing you. But I've always told you, number of molecules can change. Like all these compounds we are writing, the form in which all of them are one molecules of the compound. Like I said, a special pre-recorded class to cover the concept of molecule. It might just be a YouTube short anyway, I don't know. But let's see. Hopefully before this week runs out. Manju here, nicely explained. Thank you very much. I'm glad you are following. Please let us move on. We are going on to compound number 5. Compound number 5. Let us look at sodium hydroxide. Sodium hydroxide is a base. Number 5. Correct chemical formula of sodium hydroxide. Hydroxide. Now, from the name sodium hydroxide, you see clearly that we have sodium in the compound, and then we have the hydroxide radical or ion. The hydroxide ion or radical is OH negative. And so we do the same thing again and again. We have our sodium with its valency, positive 1. It's combining with the radical, this ion, hydroxide ion, OH negative. They will interchange their valencies. You know, write the positive ion first, the positive element, which is sodium. It is going to receive the valency of OH. The valency is negative 1. So just step down the 1 here. And you know, we don't show atomicity of 1, so I'm not going to write it this time around. Next, we combine it with the negative ion, OH negative. This OH is meant to receive this valency of 1 from sodium, which will come down as atomicity here. But I don't need to show it. I know that 1 is going to affect oxygen, is going to affect hydrogen, which means this is going to be in bracket with the 1 outside. But I don't need to show it. Like I said, reason is simple. Atomicity of 1, we do not write it. The correct chemical formula of sodium hydroxide, therefore, the correct chemical formula of sodium hydroxide is NaOH. Perhaps let us see what the correct chemical formula of calcium hydroxide will be. That guy which is called lime water. You know, if you do not understand and appreciate valency, which is obtained from valence electron. If I tell you to write calcium hydroxide now, some of you may wrongly go and write it something related to this sodium hydroxide. Perhaps Maybe somebody might be thinking that calcium hydroxide should be this. Since sodium hydroxide is NaOH, then calcium hydroxide should also be CaOH. Sadly, it breaks my heart to tell you that that is wrong. You see, valency is the key. Note, it's not. Let us find out what the correct chemical formula is going to be. Number 6, calcium hydroxide. Remember, you can support this channel with whatever that is convenient for you. This live class that is going on, you will see the chats section below. Just by the right side, you have your currency icon. If you tap on the currency icon, you can send GMAETS 41, super stickers, you can send super chats, you can become a membership. Super stickers, super chat are one-time support. If you click on it, whatever is convenient, you can support this channel with it, and I will gratefully appreciate. Membership is monthly package. On this channel, we have 2 memberships specifically for our online student. Yeah, we have the platinum membership, that's platinum level. We have the diamond level. Platinum level is 2,000 naira Nigerian currency, while diamond level is 4,000 naira Nigerian currency. If you are not a Nigerian, and you want to support this channel, of course, you can do the conversion to your currency and support GMAETS with whatever that is convenient for you. I'll gratefully appreciate that. More so, become a subscriber on this channel. I appreciate that also. All right, become a subscriber. And once you subscribe with a purpose, with a reason that this channel is going to give you something you need, the best. If you click on the subscription bell, go ahead and turn on your notification bell. If you click on the subscription icon, after that, quickly click on the notification icon. That's notification bell that is always close by, just by your right. If you click on it, a menu will pop up. Select all, so that you won't miss out on anything happening on this channel. This channel is 100% dedicated to academic work. Let us look at calcium hydroxide. From the name, we have calcium there, and of course we have our hydroxide radical or ion. By the time they combine, calcium, the valency is 2+. It is going to combine with OH negative. The valency is -1. Of course, I can feel you smiling now, and you're saying, yeah, I think I get it now. I think I can see why CaOH is wrong, why this is not the correct chemical formula of the compound. Funny enough, calcium hydroxide contains calcium, oxygen, and hydrogen. And then we are now saying that this is wrong. It's wrong. The reason is because of the atomicity. Remember, I told you atomicity is not our mate. We have to bow to it because it follows the standard obtained from valency. And of course, valency comes from valence electron knowledge. Let them interchange their valencies, and what is going to happen? I would write the positive element first, calcium. It is going to receive the valency of OH, which is 1 here, -1, but you don't need that one when you are stepping it down as atomicity. So this is meant to be Ca and then 1, but I'm not going to write that 1. Next, you have OH. There are 2 atoms of different element here. Now, you have to write that negative ion, OH. That OH is receiving a valency of 2 from calcium, which will become its atomicity. That 2 is affecting the species you have here, the 2 atoms of different elements you have in this hydroxide. For that reason, you must put this in brackets, and then you have your 2 outside. Therefore, the correct chemical formula of calcium hydroxide, is Ca bracket OH and then 2 outside. It is important for me to state very clear. Sometimes, I don't know, we don't just like the truth. or when we hear the truth, we don't walk with it. We will know that this is the truth, but allowing the truth to guide us and acting in line with the truth becomes our problem. It happens in our academic field a lot. You see, each of the topic you study or you learn, you are being taught, has a secret, has a foundation, which must be built. If the secret is not exposed, if the foundation is not solidified, students are bound to mess up in that topic, which leads to their complaining that they don't understand that subject or they hate that subject. And I always say, for me, I don't think there is anything that is difficult. It's a question of who you encounter. It's a question of your own mindset. Who you encounter, which is with respect to your teacher, and then your own personal mindset. Are you really ready to learn this? You can see the way I'm breaking this down. It's just 1 plus 1. Nothing is happening here. Just get to know the symbols of the elements, the atoms that make up the compound, and then know their valencies, they interchange. So what is the secret of this? The secret is simply what is called valency. And what should you do for GMAETS 41 and for yourself? Learn the valency of, there are 15 elements at least among the first 20 elements whose valency you are meant to know very well. Remember in our previous class, I eliminated 4 for you, those that have 4 valence electrons and those that their valence electrons are complete. I eliminated them out of the first 20 elements. So we are left with 15. I told you, go and learn their valencies. I taught you all of these things. How to get their valencies, also 1 plus 1. Then I listed common radicals for you, and I showed you their valencies. These are things that the student just needs 2 days, highest 2 days, to memorize all of them, have them at heart. And then from there, start playing with all of these. And once you capture this part of chemistry, you've actually learned a lot in chemistry. Are you following, right? So I am encouraging you, friends. This is the truth I have told you. Not many educators might either remember or have that time or that will, that desire, that passion to tell you and expose all these secrets. You have the opportunity now. Please make sure you work on that secret. It is just like this thing about multiplication table. I have been singing and talking about. As a matter of fact, yesterday I didn't come on live. Was it yesterday? I'll be on Monday. I didn't come on live for our math class. Yeah, I was down, held twice a bit. However, I used that day to talk about multiplication, which I dropped a 16-minute video about it, on this channel, encouraging scholars, whether you are in basic level of learning, whether you are in high school, senior class, whether you are in university, we all need that table to memorize it. From there, you will see how the network of your brain will explode. To expand to now help you understand various other things in mathematics. Here now, the secret is valency of these guys. Please, all these numbers I'm showing you on top, they are the secret. We are moving on. Let's now migrate to other compounds that might sound a bit weird or new to you. We are going to look at potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7. That takes us to number 7. Compound number 7. Remember, we are treating trinary compounds. Number 7. What is the correct chemical formula of potassium tetraoxomanganate 7? Tetraoxomanganate, manganate 7. You see all these number, sulfate 6, carbonate 4, now manganate 7, nitrate 5. Of course, in the next class, we are going to learn how those numbers came about, because you should know how to calculate oxidation number of elements in a compound. And once you know how to calculate oxidation number of elements in a compound, it will open your eyes into that topic called redox reaction in chemistry. So you can see that these are just chains of topics linked together, and you just don't jump any one of them anyhow. Good enough. What we are treating now is just basic. Yeah, it's actually from basic 10. Is it basic 10? I mean grade 10. High school, grade 10. In Nigeria, here we'll call it SS1. They are the ones that are meant to learn this. But you can see how far these things we are treating now, how far they go in chemistry. Redox reaction is treated in grade 11. In fact, many schools or many educators don't even teach that redox reaction. Many don't teach it. They know best why they do not. But of course, I know better. The reason is because the solid foundation leading to understanding those things, they had not taught their scholars at the time they're supposed to teach them. That's just the truth. I keep saying this thing every time on our channel to encourage you to understand that our STEM subjects are interesting subjects and easy to learn. If you humble yourself, have an open heart, be willing to learn them, and if you have a good coach. GMAETS 41 is here for you, friends, right? Let's get to business. Potassium tetraoxomanganate 7. This compound is usually used for redox titration. This compound, if you have carried out redox titration before, you would have seen it. Are you teaching organic or inorganic chemistry? This is inorganic chemistry. Is that okay? Josie Joe, you showed me a secret to study as a student today, so thank you so much, sir. You are welcome. Stay blessed. Thank you for connecting to the class. And have some on this. And the truth is, in the meantime, while I breathe the breath of life, I am committed to giving the best academically to students. That is much I can give with respect to also preaching the word of God about Jesus Christ and the kingdom of God. All of these God has bestowed to me, our helper Jehovah, and I want to give it to you, friends, free of charge. So you are all welcome to this channel. We are one big family. You are GMAETS. Let's go. We have potassium here, which is K. The tetraoxomanganate 7, if you remember in our previous class, I already gave you the valency of that radical. The tetraoxomanganate 7 is the radical written like this, Mn. This Mn is manganese. Manganese. Atomic number 25. Atomic number 25. Manganese. Now, it is tetraoxomanganate 7. So this Mn is combined with oxygen, tetra, 4 of them. Are you following? Tetraoxo, then manganate. Manganate 7. Why manganate 7? The valency of this guy is -1. The valency of this MnO4. The valency of the tetraoxomanganate is what? -1, like I said. That manganate 7. We move on. So potassium has the valency +1. We combine it with our tetraoxomanganate 7 radical or ion. And what is going to happen? They will interchange their valencies. And once they interchange their valencies, write the positive element first, potassium. It will receive a valency of 1 from this MnO4. That one will be stepped down as its atomicity. So here we have atomicity of 1. Next, combine it with our tetraoxomanganate 4. Manganate 7 rather. Tetraoxomanganate 7. You know that this MnO4 together is meant to receive 1. This valency of potassium, which is +1. To just receive that 1. So normally we are meant to put MnO4 in bracket and then write 1 outside. But atomicity of 1, we do not show it. You are aware of that. This is inorganic chemistry, please take note. But on this channel, we have complete work on organic chemistry. Like I said, almost, let's say, the 80 to 90% of your works in your core STEM courses, to include math, physics, chemistry, their works are done by training completely to kick it off. And who knows, tomorrow is Thursday or Friday, perhaps the first content, that Friday or Saturday, the first, okay, it's going to be a wonderful one. So the correct formula of this compound, anyway, let me write it. I don't want to say I'm tired of writing the correct chemical, but let's write it. Let's not be tired. The correct chemical formula of this compound. Of potassium tetraoxomanganate 7. is KMnO4. This is the correct chemical formula, this and nothing else. Any other thing written as potassium tetraoxomanganate 7 with an atomicity different from 1:1:4, that guy is wrong. If it is not this that you see as potassium tetraoxomanganate 7. This compound is also called potassium permanganate. It is also called what? Potassium permanganate. Your Adamas, I'm listening to understand where you are. All right. Follow up, okay? We are dealing with how to write correct chemical formula of compounds. We're using the knowledge of valency to do that. This class is streaming live from Nigeria, okay? A state called Anambra State. Let's move on. How about we talk about the correct chemical formula of disodium heptoxodichromate 6, or simply called sodium heptoxodichromate 6. Let's go. Sodium heptoxodichromate 6. So what are the component species, the elements that make up or that made up this compound? Sodium is one of it. Instead of sodium, we could have potassium. You see this compound? It is usually used as oxidizing agent in organic chemistry. You see this one, potassium tetraoxomanganate 7, is also used as oxidizing agent both in organic chemistry and inorganic chemistry. This one specifically. This one is used more in organic chemistry. Both of them are used in organic chemistry very well. But this first one is used both in inorganic chemistry. For example, when you are studying the oxidizing effect of sulfur oxide under sulfur and its compound, if sulfur 4 oxide reacts with this guy acts as an oxidizing agent to it. To give you some compounds to also include magnesium tetraoxosulphate 6, to include potassium tetraoxosulphate 6 in that compound. So take note of that. They are used as oxidizing agents. Sodium is one of the components of this compound. Then heptoxodichromate. Now you can hear oxo and then chromate. This hepta is a number. This di is a number. Hepta is 7. Di is 2. Heptoxo tells us you have 7 oxygen. Dichromate tells us you have 2 chromium. Chromium is atomic number 24, just before manganese. Before manganese and after vanadium. Are you following, right? Vanadium is number 23. This one, chromium, 24. And then manganese, 25. But like I've always said, just learn the first 20 elements very well yet. Have them at heart. Then from there, you can now proceed to learn others if you so wish. This guy is a radical, a ion. And the radical is Cr2O7. The valency of this whole thing, Cr2O7, the valency, the combining power is 2 minus. So we have the valency to be this. The formation of sodium heptoxodichromate 6 is not obtained from the combination of these guys with their valency. Once they interchange their valency, I'm writing the positive element first, which is sodium. Of course, you know it is going to receive this valency of 2 from heptoxodichromate 6. So these 2, the valency of this guy, heptoxodichromate, will step down to sodium as atomicity, making sodium to be 2 atoms in that compound, sodium heptoxodichromate 6, which was why I pronounced it first, disodium. Okay, write the negative radical, which becomes Cr2 and then O7. Normally, this Cr2O7 is meant to be in brackets, where it will receive a valency of 1 from sodium. to become its atomicity. So this Cr2O7 together in bracket, and then atomicity of 1 outside the bracket, which comes from the valency of sodium. But once again, you know that atomicity of 1, we do not write it. Are you following, right? So that is the correct chemical formula of disodium heptoxodichromate 6. It's not compulsory to attach the di to the sodium. So you can simply pronounce it as sodium heptaoxo di for 2. Then this chromium will become chromate. Remember what I told you? You come to the middle element, pronounce the prefix chrome, and then the suffix, the ending part, will change to 8. Sodium heptaoxo dichromate 6. Instead of sodium, we can use potassium. So we can also have potassium heptaoxodichromate 6. UL Adamas. Thank you that you helped me determine many things. You're welcome, UL Adamas. I'm glad to have you join us today. All right, friends. Let's conclude this guide. The correct chemical formula of this sodium heptaoxodichromate 6. So we have Na2Cr2O7. I guess we'll be approaching the end of this. I have 2 more compounds I'd like us to talk about. Correct chemical formula of lit2-trioxonitrate 5, lit2-trioxonitrate 5, and then we'll talk about the correct chemical formula of, since I mentioned oxidizing agent, let me give one that is used as a reducing agent a lot in organic chemistry, which is lithium tetrahydroaluminate 3. We also have its counterpart, sodium tetrahydroborate 3. So once I'm done with these 2 compounds, then we would have been done with our class today. And I want to believe you are learning correct chemical formula of compounds. Very important. Number 9. I am really happy today. The network situation, see, the network is just moving a bit cool, not much stress. So I'm not just shouting network. Oh, thank you. Thank God for this. Could you also use lithium or calcium? Is it for this? For calcium? No. For lithium? Yes, it's possible. Because lithium and sodium, they have one valence electron. That is 1 electron in the outermost shell, giving them a valency of +1. So you can use lithium for this guy. It's possible. But usually it is sodium that you see there, either sodium or potassium. UL Adams, right? I hope I answered your question. Number 9, correct chemical formula of lead trioxonitrate 5 or lead2-trioxonitrate 5. We usually pronounce lead2-trioxonitrate 5. Nitrate 5. If you don't want to put these 2, no problem. You can just say lead-trioxonitrate 5. Are you following, right? Is allowed. So when I am concluding, I won't fix these 2. I'll just mention or write lead-trioxonitrate 5, so that you will be aware that you can pronounce it in any of in either of those 2 ways, right? So here we have lead. Lead is Pb. This one now is not among the first 20 elements. It's beyond it. Okay, then we have the trioxonitrate, which is a radical. Good enough, we've seen it today. When they combine, lead is 2+. The valency of lead is 2. Then it's going to combine with this radical trioxonitrate 5 ion. Of course, there's going to be an interchange of valency, which will now become the atomicity. We'll write a positive element first, which is lead. This lead is going to receive this valency of 1 from NO3 to step it down to become its atomicity. So normally I'm meant to write 1 here. Atomicity of 1, we don't show it. Next, I will write this negative ion, which is NO3. You know that in compounds, you don't show all these charges. Plus, minus, you don't show. They have no business there. Take note. Now, this NO3 will receive the valency of 2 from lead. Now, that 2 is affecting both nitrogen and oxygen. Therefore, the NO3 will be in brackets. You now have 2 outside. So, do you see that lead 2-trioxonitrate can still be written as PbN2O6? Where the ratio of combination, the mole ratio is 1:2:6. 1:2:6 from the atomicity. So this is the correct chemical formula of late trioxonitrate, this or nothing. You must respect the atomicity. Although the number of molecules may vary, but in all of these things, I have not shown you anything about number of molecules. Like I said, each of them is one molecule, all the compounds we're rating. Don't miss out on this channel. Are you following right? If you have not subscribed, right now, as I am saying this, hit the subscription icon. Once you subscribe, go on and turn on the notification bell. There's a bell icon, click on it. A menu will pop up, click on all. The reason for that, once I upload any content, you'll be notified. Anytime we have class, you will also be notified, our live classes. Although our live classes hold on Monday, on Wednesday, and on Friday. Monday is math, Wednesday is chemistry like you're having now, and Friday is physics. The time is always 8 o'clock p.m. Sometimes I might come on 8:15 or 8:30 p.m. All right? And then the class usually lasts for 1 hour 30 minutes at most. It can last less than it, but maximum 1 hour 30 minutes. Once you're getting there, we round off. So make sure you are always with this channel. Like I said, and it's a promise, before this week ends, I'll make available this concept of number of molecules. But it's not going to be a live class. It won't. It's going to be a pre-recorded class, which I will upload. The correct chemical formula of lead trioxonitrate. You see, I have removed that 2 here. It doesn't matter. Lead trioxonitrate nitrate 5 is PbNO3 and then 2. Please, let's conclude. Let's see how far we've gone with the class. This is 1 hour 9 minutes. This is 1 hour 9 minutes. Let's look at the compound lithium tetrahydroaluminate 3. If you know how to write lithium tetrahydroaluminate 3, you've also known how to write sodium borate 3, which is sodium tetrahydroborate 3. Let me be fast. I can feel that my gen wants to go off. Lithium tetrahydroaluminate aluminate 3. My generator wants to go off. Be patient, please. Let me arrange a lighting system quickly. Or can I just be fast and round off this? Can I make it? Here we have lithium. Then the tetrahydroaluminate is this guy, Al and then H. Are you following right? And please be patient. I don't want to take any chance. And I told you something was going to happen. So I've just got to manage and for us to round off. quite dull, but we've got no choice. We just round up that compound. Just be patient, please. I'll round off right away. I told you that this is going to go off soon. So guys, you can see that it's not easy. These and many other more reasons are reasons why you want to support this channel as much as you can. Okay, very important. Monetary support is very, very important because it takes a lot. It takes a lot. So much to deliver, these talks. So let us manage this so that I can just round off. Are you following, right? Let's manage this. So the lithium tetrahydroaluminate 3. This is how it goes. We have lithium, we have aluminum, and then we have hydrogen. Now, look at what you want to take note of. Okay, these are the components, the species that make up this compound, lithium tetrahydroaluminate 3. Are you following, right? Now, you notice that this guy is a metal. This one is a metal. Hydrogen. There's something about hydrogen. You will be told that, okay, hydrogen behaves both as metal and somehow as non-metal. Imagine in the periodic table, hydrogen is placed in the metal group, metal side, in group 1. But if you are studying preparation of elements and their compound, hydrogen is classified under non-metals when you are studying preparation of elements and their compound. Now, I had told you in previous classes, one of our class, that if hydrogen is combined with a highly electronegative element, okay, if hydrogen is combined with a non-metal, hydrogen will be behaving as a metal in that case. But then if hydrogen is combined with a metal, it will be behaving as non-metal. So it has these two behavior. Watch, look at this compound, H2O. This is a pure non-metal. Oxygen, this is a pure non-metal. Oxygen is a pure non-metal there. Hydrogen is a metal. Hydrogen is what? A metal. Because it is combined with a non-metal. It is combined with what? A non-metal. So in this case, hydrogen will be behaving as a metal. This is a pure non-metal. The same thing happens in HCl, somehow like that. Are you following, right? Chlorine is non-metal. This is metal. Okay, now let us talk about this compound now, sodium hydride. Sodium hydride. It seems like power holding company have restored, I was using generator before. Take note, the petrol just got exhausted. But it seems like power holding company has restored light. So there's a changeover and we can just conclude with good lighting system. Okay, that's good. Sodium is a metal. Since sodium is a metal and it is combined with hydrogen, the hydrogen will now be behaving as non-metal. The hydrogen will be behaving as what? Non-metal in this case. So the whole idea I'm trying to explain here is that whenever hydrogen combines with metal, it behaves as non-metal. And when hydrogen combines with non-metal, it behaves as what? A metal. Look at this case. Hydrogen is combining with metal. Lithium is pure metal. Aluminum is pure metal. So hydrogen here will be behaving as a non-metal, carrying negative charge. Therefore, we have to write this out. The combination will be something of this form: lithium with its plus 1 valency together with aluminum with its plus 3 valency, As a matter of fact, this lithium and aluminum will combine together to give you a total of valency of what? 4. So I've shown you something. I want to wipe and combine them now. Lithium and aluminum together, since they are positive, they will combine to give you a valency of 4. So we have something like lithium Al and then plus 4 plus. Are you following, right? Good. And then it's going to combine with this negative guy now, because hydrogen will be behaving as a non-metal, having -1 valency. La la. I know that somehow, some way you've not seen this before. But if you've seen it before, that's good. If you have not, you are now learning it. Let's conclude, please. So what is going to happen? As usual, you write the positive guy first. So this is lithium, aluminum together. They will receive the valency of hydrogen, which is 1 here, -1. To step down as their atomicity, which means that this lithium aluminum is meant to be in brackets. So let me fix it in bracket, even though I'm going to still wipe the atomicity. They will receive 1 from hydrogen. Look at it. And then next, you write your hydrogen together with them, because hydrogen is the negative guy now, and hydrogen will receive a valency of 4 from both of them, which will now become its atomicity. Now, you know that atomicity of 1, we don't write it. So I'm going to wipe this. And because I've wiped this, there is no atomicity outside the bracket. For that reason, there is no need for this bracket. There is no need for this bracket. Okay? Good. So your lithium tetrahydroaluminate 3 compound, LiAlH4. Let me rewrite that compound. Lithium, then you have tetrahydroaluminate 3. You see the way you pronounce this trinary compound still follows the same principle of how we read out trinary compound. Pronounce the first element fully, lithium. Jump to the last and third element. Count the number of atomicity, which in this case is 4. 4, translate it to Latin, tetra. This is hydrogen, no longer oxygen. So you don't call it oxo. Rather, it will be pronounced hydrido. Hydrido. So you have lithium tetrahydroaluminate 4, right? Aluminate 3, rather. Lithium tetrahydroaluminate 3. Remember, like I told you, I'm going to teach you how all these numbers came up. You know, they are their oxidation numbers. Sulfate 6, nitrate 5, carbonate 4, dichromate 6. Is it dichromate 6? Then manganate 7. All those things are their valencies. And in the next class, I'll be teaching you calculation of oxidation numbers. Like I said, you need that topic, that understanding, to be able to withstand the redox reaction, where you treat reduction and oxidation, which will further push you into electrolysis. Because without the concept of reduction and oxidation, understanding electrochemical cells and electrolytic cells becomes problematic. So you can see, you don't just leave these topics and it's not done. It's not done. So this is the compound called lithium tetrahydroaluminate 3. Let's conclude. Therefore, the correct chemical formula of lithium tetrahydroaluminate 3 you must put this number in brackets, is LiAlH4. All these numbers, you must put them in bracket and you write them using Roman numerals, using Roman figure. That's the standard, all right, as IUPAC approves. All right, dear friends, we've done justice to how to write correct chemical formula of compounds. There could be other compounds we did not touch, because of course we cannot round off all of the compounds. The knowledge you have gathered so far from this class is sufficient. From this class and previous class, because previous class is part 1 of how to write correct chemical formula of a compound, where we treated binary compounds. This is part 2 of how to write correct chemical formula of compounds, trinary compound. The knowledge you've garnered so far is sufficient for you to be able to write the correct chemical formula of any other compound mentioned. The secret to this is simply your valency. And how do you get to understand your valency? Simply trace it back and start from atomic structure that will help you get to understand what we mean by valence electron. We've covered all of these in previous 4 classes to 3 classes before the last class and then this one. Under the live section of this channel, GMAETS 41, you have all those video lessons, so you can access them. Meanwhile, we have wonderful works already arranged for you under the playlist of this channel. How about you visit the playlist one day? Visit it. See the academic wonders of works arranged there for you already. As a matter of fact, GMAETS 41's playlist is just like a textbook in video format. How about you write the correct chemical formula of the compound zinc tetraoxosulphate 6? The valency of zinc is 2+. How about you write the correct chemical formula of copper tetraoxosulphate 6? The valency of copper is 2+. How about you write the correct chemical formula of sodium trioxosulphate 4? Sodium trioxosulphate 4. Sodium trioxosulphate 4. That radical that is there, trioxosulphate 4, the valency is 2-. So what have I said so far? Zinc tetraoxosulphate 6, write the correct chemical formula. Copper tetraoxosulphate 6, write the correct chemical formula. And then sodium trioxosulphate 4, write the correct chemical formula. I've given you the keys you need to guide you. All right? In our next class, chemistry class, next week, Wednesday, we shall be dealing with how to calculate oxidation number of elements in a compound. In that class, once again, you will find out why is it that the oxidation number of this NO3 together is -. I remember the one I showed you on heptoxodichromate 6, CR2O7. Why is it that the oxidation number of the CR2O7 is 2-? Then if I give you a compound, full compound, like we call this lithium tetrahydroaluminate 3. Lithium tetrahydroaluminate 3. Why is this guy aluminate 3? You heard when I pronounced this lead 2-trioxonitrate 5 or lead trioxonitrate 5. Why is it that this nitrogen is nitrate 5? Why? This guy told you to find out the correct chemical formula of sodium trioxosulphate 4. Why is it that the sulfate there is 4? We shall find that out in our next class. Calculating oxidation number of an element in a compound and calculating oxidation number of an element in a radical, as well as how to calculate the overall oxidation number of radicals. You wouldn't want to miss that class. You won't, because if you miss that class, it will still have adverse effect on you. This is just like a chain where if one is cut, the others are being affected. It is just like a series connection of electric circuit when you talk about resistors in series. When one is damaged, the rest are also what? Damaged. Okay? Now you need that class so as to be able to withstand the concept of redox reaction, like I've said, and of course the concept of electrolysis. I'll be seeing you in our chemistry class, next chemistry class on Wednesday. However, remember, on Friday, we have what? Physics. On Friday, we have physics. We'll be dealing with scalars and vectors more. I think we are getting close to the end of scalars and vector. Yeah, the first part of scalars and vector. I'll finish that in our next class before we now look at the last part of scalars and vector next week, which will now be how to multiply vectors. So whatever am I saying here? On Friday, we have our physics class. The same time, 8 o'clock to 9 o'clock p.m. Nigerian time, West African time. Or sometimes I come on 8:15, like I said, or 8:30. In summary, what have we learned from this class today? Simply how to write correct chemical formula of trinary compounds. And we learned that trinary compounds are compounds that contains how many elements? 3. But whenever you want to write these compounds, it's important for you to understand that they contain majorly 2 species. One is positive, the other is what? Negative. That negative guy usually is a radical that contains atoms of different elements. The positive guy, it was only one of them that contains atom of different element, which is the case of ammonium. And we stated that once you know your radical and the valency, you know your element and the valency, it's just for you to interchange their valencies. The valencies will interchange and become what? The atomicity of the respective guys. For radicals, anytime they are receiving a valency, which automatically becomes the atomicity. If the number of the valency is 2 or 3. Of course, you have to put that radical in bracket and then you show that's 2. But if it is 1, you don't need to put that radical in bracket. And don't forget, in a case where the valencies being interchanged are the same, in fact, you don't need to interchange that valency, because if you interchange, you will still do what? Cancel them off. Remember calcium trioxocarbonate 4. Then uniquely, this last compound, the way the guy formed is quite different from all others that we've learned. So you want to take note of it. I mentioned sodium borate, sodium tetrahydroaluminate 3. This guy, look at it. Sodium tetrahydroaluminate 3. How about you find out how this compound forms following this procedure? Remember that boron has the same valency as aluminium because they are both in group 3. Having valence electrons of 3. Thank you for connecting to this class, and I hope you've learned something. Share this video to your friends. Encourage them to also subscribe and join this channel right away. There is no time. GMAT 41, I wait for nobody. The world is moving, it's spinning. It's not waiting for anyone. And so I too, I do not wait for anyone. You want to learn? You want to breathe and speak science? GMAT 41 is a channel to always stay tuned to, including your maths, engineering courses. We deal with them here, breaking them down to seem like 1 + 1 for you friends. Good night, and I hope to see you on Friday in our physics class. Before that Friday, what should you do? Invite others of your friends. Share this video to them, share the channel link to them also so that they can subscribe. Tell them how you've benefited from this class also. Let them come and have a taste of it. Good night.